In this video, we're gonna prove that 1 plus I to the power n plus 1 minus I to the power n, where n is a natural number, we're gonna prove that this one is a real number. So the best way to approach this one is to write it in the exponential form. Okay, so first let z equals 1 plus I. So first write this one in an exponential form. So to do that, okay, we just know that we can write this one as the square root times the square root of 2 over 2 plus I square root of 2 over 2. Okay, this is a technique that one needs to learn along the way. So now we notice that square root of 2 over 2 is just the cosine of pi over 4 plus I the sine of pi over 4. Okay, so now we can do square root exponential I pi over 4. So this is our z. Okay, we'll get more videos and we're gonna do this one in details in the next videos. Check my other videos while I have started complex analysis or complex algebra for students. Okay, now what's Zn? Zn is gonna be the just square root of 2 to the power n times I pi over 4 to the power n. Okay, and in this case we just do square root of 2 to the power n, and here we use the exponential as we know it in R. So it's I n pi over 4. Okay? Okay. Now, what about the other one? Let's call this one Z1. Okay? Z1. Z2 is 1 minus I. Okay? Because here we have 1 plus I and 1 minus I. Let's call this one Z1 and this one Z2. Okay, Z2 is 1 minus I. We do the same thing. Square root of 2. Okay. Square root of 2 over 2 minus I square root of 2 over 2. Okay. And after that, we notice that square root of 2 is just cosine pi over 4 minus I sine pi over 4. Okay. Square root of 2 exponential I pi over 4. But in this case, we have a minus. Okay? Because remember, in the exponential form, okay, we have aix is cosine x plus I sine x. And e to minus ix is cosine x minus I sine x. Or you can think of this one, and it is in fact, this is the conjugate of this one. Okay, so if you call this one z, this is z bar. Okay, check my other videos. I'll come back to this one to do more problems on this to make it clear. Okay, now what we have, so now our big Z, let's call this one big Z. Okay, we have this one, but we need one more step here. So let's compute Z2 to the power n. So it's everything to the power n, it's square root of 2 to the power n, e minus I pi over 4 to the power n, it's square root of 2 to the power n, e minus I pi n pi over 4. Okay, so we deal with the exponents as the usual way in R. Okay, now we have Z equals 1 plus I to the power n plus 1 minus I to the power n is square root of 2 to the power n ei n pi over 4 plus square root of 2 to the power n e minus n I n pi over 4. Okay, we have this factor here, square root of 2 to the power n, and we have e I n pi over 4 plus e minus n pi over 4. If we divide by 2 and we multiply by 2 here, okay, by 2 here, what we get. So this is what? This is the cosine of n pi over 4. Okay? Remember, in the exponential form, what we have is that cosine alpha is e to the alpha plus e to the minus alpha over 2. Okay? So here, think of alpha as n pi over 4. Okay? What do we get? We get 2, okay? 2 using this value, 2 square root of 2 to the power n cosine n pi over 4. Okay, this is our z. Okay? And since everything is real, that means this one is in R. So we have proved that z, which is this one, which equal this one, we have proved that it's real. So that's the result that we want to prove. Note that we have used many properties of the complex numbers very quickly. So you need to pay attention and learn them if you want to do well and be very quick and efficient in this one. Check my other videos. I have a lot of videos on complex analysis and explanations. Thank you very much.